Okay, here we go. We're recording. Sorry, guys. All right. So I said I was going to go in and look at homeworks, and I did. And basically, like say 7.1 was due 2 weeks ago. I went in, and if you had not done it at all, not given me a submission, that is a zero. Okay, I hope that makes sense. If you did not turn something in, then I cannot grade it. So that's a zero. Now, a few of you have been having issues. Maybe it's like 1201 or 1202 or something like that, and the thing's already closed, and you've emailed stuff to me. And I've been like, okay, I see that you did it, but please submit it on D2L. So if you need me to reopen some of that, like I've talked to two of you in particular in the last couple of days, who were like, would you please reopen those folders? Send me specific folders and I will reopen them. Now, normally I don't do this, but we're living in COVID world right now, and it's stressful and people are getting behind and things like that. Now, what I'm not willing to do is I'm not willing to go back to the very beginning of the semester to 1.1 and reopen that for you, okay? But if it's something in the last 2 weeks, 3 weeks, something like that, and you're like, oh, I just didn't get 7.1 submitted. Oh, I just didn't get that proofs project submitted, which, by the way, right before class, I looked at the proofs project and I saw how many have not submitted it yet. So if you haven't submitted that, I have not turned it into a zero yet, but you're probably going to want to submit something. So I don't know, when did that one close? Is it already closed?
It closes tonight.
Yeah, so if you don't get it in by when it's closing, then let me know and I'll reopen that folder for you. I'm not problem like that.
I have a question about the proofs done due today.
Yes, ma'am.
I had like an exam due or an exam today, and I also had the project for your class this week. So, is there any way we could turn the proofs in next week?
I don't want you working on them next week because we have the test next week, but I don't mind giving an extension on Proofs Project if y'all need an extension. Do people feel like they need an extension on Proofs Project? Because it's due tonight.
Sunday maybe.
Yeah, I think. What else do y'all have outstanding?
The video presentation.
Okay, video has to be turned in by tomorrow because it has to be there for other people to comment on. So, and in fact, good job, guys. I've noticed we've got about 6 of them. And yes, Mary, I saw your presentation up. So I've got about 6 videos already loaded up, 5 or 6, and I've already noticed some people responding back. So again, your video presentations are due by tomorrow at midnight, 11:59 p.m. So that one, I'm not willing to change that due date, and you really need to get that done or else people can't respond to you. And the responses to videos is due next Wednesday. Is that the 25th? I think it's the 25th. Okay. So those two need to stay firm because I just don't want to push those off. However, okay. So, however, I'm okay with moving the project or the proof project. So Demondre has recommended Sunday at midnight. And I will be glad to do that. If that lightens your load a little bit, Alexis, and different ones here in Commerce also nodding. So hang on just a second. What's today?
Tonight.
22nd?
Yes.
Okay. So I do not mind pushing that off a little bit. Some of you probably worked on it and are like, ah, dang it. I worked hard to get it to out today, but you're done. No problem, Alexis. Okay, so that's there. But don't push it off too long because we don't have too long to push it off. Okay. Jessica, yes, ATC is in Ferguson. Mary, good job setting up your presentation. Samantha, you submit the videos. What you're going to do is you're going to click on So this is your video. You're going to click on activities. And then once that little drop down menu comes down, you're going to click on discussions. And there's a big thing about presentations, semester-long presentations, semester-long project presentations, and a big, huge write-up with all the stuff that I'm expecting. And down on mine, it looks like toward the bottom, it says, I had to add a topic down there, and it says presentations, and like you can see where people are submitting. And if you need to start your own thread, you're welcome to start your own thread in there and submit that way. That's fine. Okay. Now for the write-up, the write-up was due on Tuesday, and that should have been submitted into an assignment folder. So there are two different things. The write-up in the assignment folder, and the video is the presentations under discussions. Yes, Maria.
You did say 11:59, and it does say that on here. I was just making sure that it's not 5 p.m. like it says on the paper that you had given us. Due by 5 p.m.
Yeah, that was when we were going to do it in class.
But 11:59 is fine.
Yeah.
Okay.
Absolutely. Yeah, because we've just kind of moved on to virtual world. 2 YouTube videos is great, Samantha. No problem. Just load links to both of them. Okay. So we got that out there. There are a couple of little quizzes running around, so don't forget about those. They're mainly for participation for the next couple of weeks. So just go into D2L and look at them. One is on your level of activity for the presentation. It's set up as a group thing. So if you're not in a group, you just put not applicable and move on. Okay, nobody right now is in a group this semester. That's okay. And then you answer all your individual questions, like how much effort did you put into the background research for your presentation? How much effort did you put into finding your activities? How much effort did you put into putting your presentation together? That kind of stuff. So it's mostly a kind of an evaluation of your time and effort into the project is what I want to know. I think there's even a spot that says, let me know if you have something else to tell me.
You also have a sheet that was like an evaluating yourself or your group. Do we still fill that out and upload that or no?
No, I changed it into a quiz.
Oh, thank you.
So you don't have to submit that separately. You do it as a quiz. Good question. Yeah, okay. All right, so quizzes in D2L. Mary, I'm sorry, I don't know off the top of my head. Maria, are you in there? Are you in D2L right now? Can you tell me when those quizzes are due?
That's what I'm looking for.
I'm like, I don't know off the top of my head, Mary, I'm sorry.
Drawings of 3D objects. That one's due on November 30th.
Okay, November 30th for one of them, and
Also November 30th, group and individual evaluation.
good. So these are basically like participation grades. One is about the class that we had last week on different types of drawings. And one, and if you were there or in Zoomville on that day, or you've watched the video, you should be fine. And then one is about your participation levels in the project. Both due on the 30th. And there's a couple of little things like that out there. There is a reflection project that's been out there for a while. You are, of course, welcome to do the quizzes early. Welcome to do the reflection early. Get them done, get them off your plate, and move on. I think this one is due next week sometime.
It should be an open assignment.
Mm-hmm.
It's way at the bottom. I've seen it, I just couldn't find it.
Way at the bottom, as she says. Hiding. So the reflection, I believe your first reflection was on things in the class that were helpful.
Wait, it disappeared.
Uh-oh.
The last thing is the project self and group evaluation.
Okay, let me,
I'm not sure either.
okay. I'll go online and make sure it's assigned. It might be hidden. Sometimes they are hidden from students, so. I'll get you that information, but the reflection, I think this one is what stuff that was not so helpful in the semester. So it's like, and you'll just write a paper on it like you did, just a little paragraph and enter it. So it's not too terribly bad.
And due date.
I don't know. Let me look at it. Let's make it 11:30. That way everything's due before I have to get your grades on for the December 1st.
And then that quiz that comes after the test to let you know. what
Okay,
will be taken by.
so that's my next step. So I will get everything, your grades on by December 1st, okay? On December 1st, if you are not taking the final exam, if you are happy with your grade, then you will take the quiz on the final exam and you will tell me, I am happy with my grade. I am not going to take the final exam. Okay, and that is lovely. This is open on December 1st. It's already there, but you probably can't see it yet. And it will be due on December 3rd. So that is 2 days later. This is Tuesday. This is Thursday. This is review week. So this is week 15 that we're talking about. So 2 weeks from now. And so my plan is this December 1st is the day that I'll make a video about the final exam and I'll post it. And in fact, I think there's already a spot in week 15 that says here. And I just haven't made the video and posted it yet, but the link is not, it's there, but it's not active yet. Okay, so I will make it available here for the video. And then on December 3rd, that's the third day, that's the day I'll have a Zoom meeting. If you are taking the final, you will know by December 3rd. So you can watch this video, you can come to the Zoom meeting on Thursday, you can visit with me, ask me specific questions. If you're not taking the final exam, you don't need to do anything except for this quiz during review week, and then you are done. If you are taking the final exam, you should watch the video, come to the Zoom meeting if you have questions. Yes, ma'am.
So everything should be graded by then, and whatever our grade is, then will be our grade if we decide not to.
December 1st. Yes. Yes. So whatever it shows. So in the quiz, it actually says, go into the grade book, make sure that you have a grade for all of the assignments that are showing, and then tell me what your grade is what I've asked you to do. That way we all know you have an A, or we all know you have a B, or whatever. Okay. And then based on that grade, are you happy with that grade? If you are happy with that grade, then you're just going to walk away and that's the grade you will get. And basically it's averaged out of 75% of your grade. If you're not happy with that grade, maybe you missed exam 1, okay, you didn't take exam 1, you need to replace a 0 or something like that. Then you'll say, this is my grade, I am not happy with that grade, and I want to take the test here. And then there's options for different things like that. The provost has recently told us, just last week, that suddenly we're okay if we want to come back for final exams. He's been telling us all semester we should not bring people back after Thanksgiving. So I'm going to be here anyway. So if you are like, I really like a face-to-face test and I want to come in to take that final exam, if you're taking the final exam, then I'll be here. And so you can just come in during our testing time, which this class is Tuesday at 1:15 is y'all's assigned final exam time. And so if you want to do that, you can just come in, meet with me, no problem. We'll take it right here in the classroom, no big deal. If you're like, I'm in Terrell or I'm in wherever, we'll work that out if you're taking the final exam. So I'm not going to stress about final exams yet if people are like, oh, I'm good. All right. We'll have week 15 and week 16 to sort out who needs to stress about a final exam. All right. Yay. But there will also be online proctoring options for final exam week if you don't want to come back face to face. No problem. How's that sound? Sounds like a lot of stuff still going on.
A lot.
The big stuff is your presentation, Get that done in the next day or two, right, today or tomorrow. And then the test on Tuesday. And if you do well on those, then most people won't need to take the final exam. It's my experience from the past. Some of you may still want to. That's okay. Sounds good, Samantha. I will get it to them the night before. All right. Cool beans. Let's talk about the test. You have a test on Tuesday. Hope everybody used their Tuesday without a class productively to get their presentations ready and maybe study a little for the exam. Did y'all just sleep? We're not going to do that. We're going to sleep. All right. Bum, bum, bum. Let's look. I loaded last week some sample problems into D2L. Looks like this. There's 4 pages, 2 pages of questions and 2 pages of solutions, right? I think it's in both this week and next week. I think it's both week 13 and week 14. Yes. As far as format, your test will look very much like your first test did. So I'm not going to throw any crazy curveballs at you. There's going to be a little bit of true false, a little bit of multiple choice. Those are worth 3 points. A little bit of short answer worth 4. A little bit of calculations or proofs worth 5. Okay, so that's just my standard process for a math education class. The more work you have to do, the more points it's worth, right? So it will look very similar to what you're used to. I really like those questions where you have to either figure out angles of things or you have to tell me what's wrong with a picture, just like I did on test 1. The difference being that test 1 was primarily special angles on parallel lines, yeah? And this one is going to be primarily triangles, quadrilaterals, and circles. Okay, so the content's slightly different because we moved on. Yay. Oh. All right, so anything on those sample questions you want to take a look at? It's all good. Excellent review session. Let's go. Maybe not.
What week did you say? 14? Or 13?
It should be in both weeks.
I see.
It says like sample
I think
problem.
it's 13 and 14, and I think also in 12.
I've been trying to get y'all to study. Especially people who aren't coming to class and they're just watching videos. I want them to study, get out there ahead of it because they may have more questions if they can't see me daily. I haven't looked at it. Aw. Okay, no problem, Mary. Well, how about I just start at the top and we just go through and see what y'all remember, what we don't remember. I'm sure that number 1 you will probably remember. The question says, are these triangles congruent? And it's got a picture that looks kind of like a weird bow tie. Okay. And it says, are the triangles congruent? If so, give the congruency postulate and explain your answer. So this bottom corner here, let's see, it's 24. Yeah, but I'm yeah, is this E up here, G down here? Is that an it's A in the middle?
Where your hand is, I think it's an N.
I think that's the one I was trying to figure out. I think it's an N, so we'll go with N, and a C down here at the bottom. Okay, So 24 centimeters on this segment EG, 24 centimeters on this segment NC. This angle down here at G has a congruency on it, and it matches with this one up here on N. And then I've got two segments right here. EA is marked as congruent to AC. I think that's all I get in there.
Oh, you put that, the other two sides were 36. GA.
Oh, there is a 36 in there, isn't there? 36 centimeters GA and 36, thank you, centimeters AN. Okay, so this is the information I have. And it says, are the two triangles congruent? If so, tell me why.
Well, I think you were going for, like, at first, you would want to say no because it's angle side to side, but because angle GAE is going to be congruent to NAC because they're vertical angles,
Ooh,
it would be, so it'd be like side and side or any of the other ones.
We
So do side, side, side,
Oh, yeah.
because
On the
we have
front side.
the measurements are equal and then the two congruent sides.
Okay, good. So I'm hearing a couple of things here in Commerce. One is that EAG, this angle right here in the middle, is vertical, and I love the terminology. I love that y'all have this great vocabulary going. NAC. Oh,
That's why I use them.
those are vertical, and so therefore they have to be congruent, right? It's not a given piece, but we know it. So we can add that in. So what we couldn't do, and I heard this, and this was good, is we couldn't go side, side, angle. Okay, so that is not a triangle congruency. But I also heard now I could do angle, side, angle, or now I could do side, angle, side here. Or I could do this side with that side, this side with that side, and this side with that side. So I could do side, side, side. Okay, so in the realm of testing, if I gave you something like this, you would say, of course, yes, these are congruent. But then you would tell me your reason, and you need to back it up, right? So if you want to use angle, side, angle, I'm good with that, but you need to explain that this second angle is congruent because they're vertical, okay? So that's the and explain part, right? Okay, if you want to go with side, 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 that is just fine. And you'll just match them up, basically, that the EG is congruent to the NC and so on and so forth. So no worries there. You can totally just give me your reason. What else did we say? Side, angle, side. That one works. Also, because we now have two angles congruent, we know what about the third one?
It's congruent.
It's forced into congruency because of the 180 degrees. So don't forget that one. So you could pull some other congruency as well. You could talk about angle, side, angle or something if you wanted. Okay. All right, number two. Number two says, what's wrong with this picture? This one, we did some of this for test one. So I think we're probably pretty good with it, but just in case.
Doesn't the exterior of B have to be equal to A plus 120?
It
And
does.
that's not possible because 120 is larger than 110. It have to be -10.
That's just a negative angle. So Summer says, if we use that exterior angle postulate, we know 110 has to be equal to 120 plus A. And that's not possible because A would have to be negative, and we cannot have a negative angle inside of a triangle, right? It just doesn't work that way. So that is one of the things that's wrong. There, you could see other stuff wrong too, though. So not.
For that,
How big is angle B here?
70.
How do y'all know that?
Or it's 180 minus 110.
Okay, this guy right here is a linear pair, right? those guys, I should say. And that makes it 180 degrees across there, so that's gotta be 70. But what about 70 plus 120?
That's already 190, yeah, then that's the thing.
Right. Okay, and Ashley says that's already 190 and I haven't even added in A yet, so of course we can't have that. We can only add up to 180 degrees.
Would it work if I was a negative 10 degrees? Again,
Well,
no, that's what.
you could get there, but yeah, and what you see there is actually a similar problem to what we had earlier, right? We need a negative angle in order to make this work out. That's just not gonna work. Okay, but the way you approach that problem, again, on the test, totally individual, up to you. So depending on how you see it, just those types of problems, make sure that you support your answer so that I can follow your logic. Okay. Number 3 says, given the following figure, if CN is congruent to WN and LC is congruent, I'm sorry, that's an angle C. It's congruent to angle W, are these two congruent? Okay, so the picture looks like a crown. Something like this. Okay, so I've got CRN. Oh, look, crown. I was really witty that day, crown. All right, and we've got this angle C marked congruent to this angle W. And we've got CN congruent to NW. And what we're being asked is, can you show me basically that RN, this little guy here, is congruent to NO or ON? True or false?
True. You also have that angle in R and no.
No, she has it marked on here, the C and R is congruent to
Oh.
W and F.
So we have angle, side angle, and corresponding parts of CTC.
Okay, so I'm hearing here we have some vertical angles that apparently are marked on my picture, even though it wasn't given. Okay, so, but we know it's because they're vertical angles, right? So that's good. Okay, and so I'm hearing I have angle, side angle, side angle for these two small triangles. Triangle now, and triangle, I don't know, horn. Okay, and so because those two are congruent because of angle, side angle, then I heard I have CPCTC. Corresponding parts of congruent triangles are congruent. So therefore, yes, we do know that RN is congruent to ON. See how easy this stuff is now that you've had a month or so to look at it? You're looking back going, oh man, I rock at this stuff. All right, number 4. What's wrong with this picture? Dang it, all these pictures I have to draw. I should have printed this out. All right, basically I've got a bunch of exterior angles that are being created. Exterior. All right, so look at your D2L if you haven't printed this out. All right, so I've got, I didn't even label this stuff. I've got 135 degrees up here. This exterior angle here is congruent to this exterior angle out here. And it's also congruent to this exterior angle out here, which is 49 degrees. And then this guy up here, the exterior angle is 154 degrees. So there aren't any letters So let's give them some, shall we? A on the top here by the 135, B over by the 154, C below the A, D below the C, and E over here by the 49, just to make it so that we can talk about the picture. We need labels. We all do it, dang it. All right. So what's wrong with this picture? That's the,
Angles don't add up right.
which angles? Angles.
Well, we know that the angle E is gonna have to be, or I guess DEB is gonna be 131, as well as EDC and DCA, because they're all linear pair congruents. And
Okay.
then
So I'm hearing this makes up a linear pair. The outside guy is 49, so the inside is 131 on all three of these. Okay, I like that. And what?
ABE is gonna be 26 because of the linear pair there.
Okay,
Those, all the interior angles don't add up to 540, which is what they should. It's 554.
okay. Okay, so what I'm hearing is if you took the time to find all those interior angles and then add them up, this is a 1, 2, 3, 4, 5-sided object, a pentagon, and the interior angle should be 540 degrees, okay? If you don't know that number, you just don't have it memorized, that's okay. You have the formula for that, right? And everybody knows that? Hold that thought for just a second, Ryan. I like it because that's where I was going with this. Okay, so the formula for interior angles is, let me put it right here, 180 times n minus 2, right? So because this is a pentagon, it's a 5 minus 2, that's 3. 3 times 180, that's 540 degrees, and that's where she got this number from, right? But she said, oh, the interior angles don't add up to 540, they add up to 554, so that's a problem. Okay. But on the other side, I have Ryan, who has a different problem with this picture, and that was actually my problem with the picture. So, and again, if it does not matter, right? Just find a problem with the picture and then tell me what it is. And it can't be that I didn't label the corners. Dang it. I will try really hard on your test to label the corners. Okay, Ryan says the exterior angles should add up to 360. Okay, and remember this is on any polygon, right? It doesn't matter because we did that activity where we shrunk this down to where all the vertices became 1 point, and we saw that the exterior angles went around in a circle. So the exterior angles are 360 degrees no matter what. I mean, I could have a 20-sided polygon here and I shrink it down to 1 point and exterior going around, it's still 360, right? So that's exactly right. So he says, okay, he added up 154. What's the exterior on this guy? 45. Thank you. And then there should be 1, 2, 3, 49s, right? Because those are all congruent. They're all marked congruent. And what does that give me?
346.
So he says, look, that's 346 and it doesn't equal 360 degrees. And so that's a problem. Okay. And that was actually, when I saw all the exterior angles, that's where my head went, was just add up the exterior angles. I needed to find this guy right here. But if you went for the interior angles, absolutely true. More than one way to skin our cats here. All right. Okay. Number 5 says true or false. If it's true, give a reason why. If it's false, give a counterexample. You can find the measure of an interior angle of equal angular n-gon by using, I like this one because we haven't really done much with this, which means we're going to have to think for a second. Okay. Okay, so you can find the measure of the interior angles of an equal angular n-gon by using this formula, which looks a heck of a lot like the interior angle formula that we just had a minute ago, except I'm dividing by n. So let's think about it first. What does that do for me? I heard a true. I got a couple no's. True, true. What does this divide by n thing do for me? Let's see. If I was talking about a triangle, equiangular. Now make sure it's not equilateral because for the triangle, it has to be both. But for other n-gons, it does not have to be both, right? So what they're saying for the equiangular is that all three of those angles are the same. And we know, hey, look, the inside angles of a triangle are 180 degrees. Divide by 3 gives me 60 degrees. So each of those angles to be equal must be 60 degrees, evenly split. That's what we mean, right? Okay, so they have to be a 60 degrees. So that one we know. But what about a quadrilateral? And I'm going to do rectangle because I want to make sure I'm not doing a square. I don't want it to be equilateral. I want it to be equiangular. Okay, lateral meaning sides, but angular, of course, meaning in the corners. Okay, so we know a rectangle has 90-degree angles, right? And we know that a quadrilateral has 360 degrees. When I divide by 4, sure enough, I get 90 degrees. So it seems like it's working. Why? Well, will it still work? Will it work for a pentagon? Will it work for a 20-sided n-gon? What are we doing every time?
How do you find the number of angles?
Okay, we're finding the total interior degrees and divide by the number of angles. Now, it's a little bit tricky because the n-gon means that that's how many sides it has, right? But we know it also means how many angles it has. Like it would come from, n-gon would come from how many sides it has. But we know a pentagon also has 5 angles. Okay, so they go hand in hand. So what we're saying here is, okay, you take the total interior angle degrees and we divide it up evenly by how many angles I have. That gives me that equal thing. Is there any counterexamples of that? No. So why is this going to work? Like, explain to me why it works. It's pretty obvious, I think, but.
Kind of what you guys said, at least it's what I would imagine myself having written for them. Figuring out the total number, the total amount of space that's going to be within that polygon, and then you're dividing it by the number of sides it has, but because the number of sides is also the number of angles,
Okay.
variable.
So basically, like, think of it, I agree. So think of it like I have a total number of degrees and I need to divvy it up amongst the angles, right? And so we are doing it when we do divide by n, we're doing it summarily, just boom, I'm just going to divide by 5 here. But we know, or hopefully we know, that we could take it and go, okay, you get a degree and 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 you get a degree. And I could just divvy it up amongst however many angles there are. And when I'm finished, they'll all have the same number of degrees there. Okay, exactly right. Yeah. All right, we haven't looked at that, but now we have. You guys can do it. Stage 2. Prove the following. The diagonal connecting the vertex angles of a kite is the perpendicular bisector of the other diagonal. Oh man, kites. Been a while since we looked at kites. This was probably like the week after test one, or maybe 2 weeks after test one. Been a while. So they say you've got a kite. Somebody remind me of the definition of a kite? I'm going to call him Kite. K-I-T-E. Very original. Definition of a kite. Two pairs of consecutive sides are congruent. Yep. So that means in my picture, IT is congruent to TE, and KE is congruent to KI. And that's what makes it a kite. Two pairs of consecutive sides are congruent. Okay. So that's just definition of kite. And then they're saying, hey, look at your diagonals. And we actually proved this. It's been a while. Look at your diagonals, and what it says is the diagonal that connects the vertex angles, that's KT, this diagonal. The diagonal that connects the vertex angles of a kite is the perpendicular bisector of the other diagonal. So what we're saying is we have this guy right here, and what we're trying to prove, so given KITE is a kite. Okay. Prove KT is perpendicular to IE. That's one thing. So there's two things we're talking here. One is perpendicular. That means we have to show that these are 90-degree angles. Okay. And that let's get a point in the middle. I'm going to call him M for midpoint. IM is congruent to ME. I'm congruent to me. Oh my God. It's late in the semester, guys. That's terrible.
That's an accurate statement.
I am congruent to me. Oh, terrible. All right. So two things to prove. How am I going to do it?
Would you be able to say that KIT is congruent to KET as part of the definition of the kite?
Can we use,
I remember proving it.
can we use the side that they share? The middle line. Because I think we know that this congruent for both triangles.
Which ones are you trying to do? But yeah,
KT.
the answer is yes, but KT?
Line KT.
All right, so both of you are talking about the bigger triangles, so let's look at those first. I like it, so first we're talking about this bigger triangle, Kit here, and I guess Ket here. Sound too much alike, but the bigger two triangles. So Kit and Ket, we want to show that they're congruent. And I'm hearing that this long diagonal is one of the sides on both of those. And why does that help me, Demondre?
Because you can use the triangle congruency possibly with the side.
Side. Absolutely. So first thing we're hearing is that these two triangles are congruent to each other. And the reason why is because of side. Because we already have these two congruent sides. And if we talk about KT as one side of both triangles, then that's the same segment identity. We're done. Okay, that's side. Good. Okay, how does that help me? What were you talking about, angles?
Also angles. IE bisector, so when you look at the smaller triangles, you can say that the bisector part, congruent angles are also going to be equal to each other.
Okay, so let me, can I stick a little congruency here and a little congruency here for these two triangles? So, or angles, I'm sorry, ITM and ETM, those are congruent because they're angles on these bigger triangles, which are already congruent. So because they are, they must be congruent to one another in corresponding parts. Okay, so that helps me with these little triangles, is what I heard. Okay, so let's just look at this little triangle, ITM and ETM. Now I have side angle side, right? Because they already have these sides congruent. We just showed that these angles are congruent, and same thing, this MT is the same segment on both triangles, right? Okay, so let me put a little hashy thing there. Okay, so now I have triangle ITM is congruent to triangle ETM, and I heard side angle side. There's probably other ways to do it, but so now what does that do for me? Okay, it gives me these guys right here are congruent, so I'm going to go IM to ME. That gives me this piece right here, right? Because those are corresponding parts of those little triangles. So they have to be congruent. Now we're going to have to be a little bit tricky with the 90-degree part, because nothing that we have about triangle congruency tells me a particular measure on one of the angles, right? So we have to be a little bit more picky about that. How am I going to show that these are 90 degrees? It's not hard, we just have to work through it. Are these two angles the corresponding parts in these two little triangles? And I'm picking on this little triangle. You could have totally done that, those bigger, small triangles. It doesn't matter. So, yep. Okay, so if these two angles are congruent to each other, but I don't know that they're 90 degrees yet, but what?
Linear pairs, so they are forced to be 90 degrees each.
Because they have to add up to 180, right? So it goes something like this. Angle IMT is congruent to angle EMT. And that's because they're corresponding parts of congruent triangles. But we also know that angle IMT, the measure of that guy, plus the measure of angle EMT is 180 degrees. And I heard that was because they're a linear pair. Okay. And now we're pretty much home free, because we just need in our proof, and we were writing out the proof here, which I don't intend to write out the proof because it just takes a little more time. Let's see, Mary says, say that since the angles are equal and that they are supplementary, they have to be 90 degrees. Yes, ma'am, exactly. Okay, so what we're going to say here is that at some point in our proof, we need to put in the little statement that says, because they are congruent, that means that the measures have to be the same. The measure of IMT equals the measure of EMT. And how do I know that? It seems very obvious, but you have to put it. If you don't put it, you're going to lose a little bit of points on your proof. Because here I'm dealing with congruency, and here I'm dealing with measurements, right? So I need to make the transfer. Definition of congruent, absolutely. Yeah, but you have to make that transition. You have to go from congruency into measurement. And the only way to do that is to use the definition of congruency to say, because they are congruent, that means they have equal measures. Absolutely. So that's why this piece of it's a little more tricky, but it's not crazy. You can do it. All right, so now in my proof, I would say, so therefore, since this one equals this one, and you could substitute or you could do all kinds of stuff, it looks like 2 times the measurement of INT is 180. You can divide by 2, so the measure of one of the angles has to be 90 degrees. Okay. So now we have that they're perpendicular right there, and we have that those two pieces are congruent. So it is the perpendicular bisector of the other diagonal. Yay. That's kind of a fun thing to me right there, where you get to go, oh, it makes sense that if they're congruent and they make a linear pair, they have to be 90 degrees, right? Isn't it?
I've been dying to say it since we were talking about the side to side side. If we had named it KITA, we would have been able to say kit is congruent to cat. Kit cat.
Man, I missed a perfect opportunity. Okay, go in and make this an A. Maria says Kit Kat. We could have done Kit Kat. Dang it. Dang it, dang it, dang it. But I had Kite. Yeah, that would be fun. Feel free to use Kit Kat on your test if this is one of your proofs. It would be fun.
Is that a hint or no?
No, I haven't written it, so I don't know. There will be a couple of proofs. It'll be similar to your last test, where I'll probably have a flowchart proof that I've got pre-filled out for you. You just have to fill in the blanks, basically. And then there will probably be 1 or 2 formal proofs. Yeah, but I haven't picked them yet. I'm sorry. Can't tell you because I don't know. All right. True or false? The opposite angles of a parallelogram are congruent. Give an example or a counterexample. Because if it's false, then we need to show an example of why it's not true. Right? Opposite angles of a parallelogram are congruent. Man, Kit Kat. I'm going to call this guy Quad. Q-U-A-D. Demondre says true. He wants angle A and angle U to be congruent. We do know that this guy is a parallelogram, which means opposite sides are parallel.
We also know that the adjacent angles are supplementary.
Okay, so consecutive.
Consecutive.
A is supplemental to Q, or A is supplemental to D.
We can then use that to, like, A, the value of A doesn't change, so Q and D have to be equal.
Okay, so basically what I'm hearing is something along the lines of this. Measure of angle Q plus the measure of angle A is 180 degrees. Now remember, this is a true false. This is not a proof. So you don't have to be as formal. You don't have to do the 2 columns or anything like that. You just have to give me a reason, right? So these two add up to 180. And I heard measure of angle A plus measure of angle D adds up to 180. So basically I can substitute out. Okay, if they're both equal to 180, I can go, okay, stick this guy up here. So measure of angle Q plus measure of angle A equals the measure of angle A plus the measure of angle D And of course, I can subtract the measure of angle A off both sides. So I have measure of angle Q equals measure of angle D, which you guys did the other two angles from what I had marked, but that's okay. Those are still opposites, right? Absolutely. So it is true. Demondre's right. And again, if these are true falses, you don't have to go really, really in depth. You just have to give me the idea behind what you're saying. So if you were using the supplemental idea, you could say, oh, I know that consecutive angles here are supplemental. And basically, if I do this and this and this and this, then I could drop the A's out. You don't even have to be as formal or rigid as I'm being here, which this is really not rigid at all. So, right? True. All right. Be sure you know all the properties of the various quadrilaterals, i.e. rhombus versus rectangle. So what's the difference between those? Okay.
The rhombus has the equal sides, but it doesn't have to be 90 degrees.
Okay. So the difference between these two quadrilaterals is that the rectangle has to have 90-degree angles and the rhombus has to have 4 equal sides. Okay. And then we get this thing where we put both of those properties together and we get a what? Square. So if you look back at that quadrilateral handout that I gave you a month or so ago, it'll actually have those pictures, right? The rectangle here, the rhombus over here, and then the square is kind of combining both of their properties. Yeah, so make sure you know the difference between those, the different properties for the different ones. If you don't have them all memorized, then it's okay. You might have to prove something. Okay. All right, so looks like we can make a switch to circles here. Make sure you know those different properties. I didn't go into them on your thing. You have a handout for it. Go look. Number 8 says, fill in the blank. If two chords in a circle are congruent, that's like this guy and this guy are congruent. Okay. Then their somethings are congruent as well. There was a property that we had. Not inscribed. It is an I word. What did you say, Maria? Did you say inscribed also?
No, I mentioned the arcs.
Which arcs? What's that word? These guys out here? But what was that word? It's an I as well. It's not inscribed, it's intercepted arcs. Y'all remember that one? Only been a couple of weeks since we did circle. My hand, I can't believe we forgot it. No, I'm kidding. Yeah, intercepted arcs. So these arcs that go along with it, basically what makes this section here, we get a sector of the circle coming out. That arc also is congruent to the other arc. Yep. Intercepted arcs are congruent. Well, absolutely. That was a property. We actually showed it. So all good. Number 9, inscribed angles. Oh, this is a proof. Sorry. Inscribed angles that intercept the same arc are congruent. Okay, so this one looks like, okay, let's say we've got an A here and a B here. if I make this guy versus this guy, C and D, then what we're saying is that ACB is congruent to ADB, right? So inscribed angles that intercept the same arc are congruent. Here's my inscribed angles. She knew their kind. Y'all remember this one?
I know that we did talk about any two angles that are formed that meet at the same point will be equal.
And inscribed, remind me again what inscribed means in this case?
So like the outside angles of the circle, like relevant to the parallel sides.
Not for.
Well, they're not necessarily parallel. They don't have to be parallel, right?
I'm sorry.
That's okay, yeah. So, the endpoints and the vertex are all points on the circle. That's what the inscribed angle means, right? So they're all on the circle, and I am stinking out of time. How'd that happen? Okay, so my thought is this, and look at the hints that I gave you on the solutions and all that, but my thought is work on triangles because they share that side. Does that make sense? And you're trying to prove this angle and this angle are congruent. Look at my hints that I gave you. But I think we're gonna remember that when we're trying to prove things in quadrilaterals and circles, a lot of times it comes back to triangles. So look back at your properties. So sorry, I didn't realize we were out of time. 10 is an explanation for what pi truly represents. We did an entire big day of activities about pi. So make sure you've got that. And then it says, remember, these are only sample questions. Anything we've done is fair game. The reason I put that in there is because since I made this up, we have covered more material, right? So we did prisms and pyramids and surface area and volume and all that. So don't be surprised if I throw a question or two on the test, even though we don't have this in here. Okay? All right, sorry, we're out of time. Let me call roll real fast and we'll get out of here. If you have questions, you can hang around. And when I call your name in Zoomville, have a good weekend and study hard for your exam. I'll stop the recording.